Alright, Lecture 3, Chapter 1, Section 3. This should be some review, if you guys remember SOHCAHTOA and things like that. We're going to go over the basic trig functions. The 6 basic ones. You've probably gone over sine, cosine, and tangent before, but maybe not cosecant, secant, and cotangent. Alright. Then we're going to review the Pythagorean theorem and the distance formula and what quadrantal angles are. Remember, last lecture we talked about quadrantals. Now we're going to talk a little bit more about the quadrantal angles that we talked about, right? The north, south, east, west, the 0, the 90, the 180, and the 270, okay? All right, so let's talk about how we define our trig functions. And remember that they're all defined based on right triangles. We're defining these, okay? And later on we're going to get into the unit circle. All right, but we must have a right triangle. And one of the sides of that triangle needs to fall on either the x-axis or the y-axis. When we're doing these, it's always on the x-axis, though. I'll explain why a little later. All right, but we can apply the distance formula here. Notice we have x, as a horizontal component, and we have y, which is a vertical component. So eventually we're going to get into vectors that have a horizontal and vertical component. But for right now, r, you're used to calling that the hypotenuse. It is the hypotenuse, but it's going to be kind of our radius as we move around the circle, okay, in order for us to calculate theta here, okay? So the distance formula for us is r equals the square root of x squared plus y squared. That should be familiar too, right? That's just a solved version of the Pythagorean theorem, right? You knew it as a squared plus b squared equals c squared. Alright, this one would be r squared equals x squared plus y squared, and if we solve for r, we square root both sides. So r is the square root of x squared plus y squared. Alright, so the 6 trig functions is always going to be sine of theta is y over r. Or you learned it as like y over h. Or you learned it as opposite over hypotenuse, okay? Opposite over hypotenuse, that's how you learned it. But I want you to think of vertical over the radius or vertical over hypotenuse in this case. So cosine of theta is x over r. You learned it as adjacent over hypotenuse. But we have x over r, so it's the horizontal component, okay, over the hypotenuse, or the magnitude. So I want you to start thinking of sine as a vertical piece, cosine as a horizontal piece. All right, and then we have tangent, which is a ratio of vertical over horizontal. Vertical over horizontal. So y over x. Start thinking in terms of y as a vertical component, x is a horizontal component. It'll make it much easier as we go through this. You always learned it as opposite over adjacent, or adjacent over opposite. Either that's fine, but when we start giving it an actual specific variable that's tied to what it's actually doing, I think the trig functions make a little bit more sense. All right, so we have the inverse trig functions. Okay, notice cosecant always goes with sine. All right, so sine of theta is y over r. Cosecant is that flipped or inversed. Okay, so cosecant for you, what you're used to is hypotenuse over opposite. But and how we're going to use it, all right, it's our radius or our magnitude divided by our vertical component. So sine and cosecant are inverses of each other. Cosine also has an inverse. The inverse of cosine is secant. Notice it's just cosine ratio flipped. Okay, it's our magnitude divided by our x component. So know that cosecant goes with sine and secant goes with cosine. And tangent goes with cotangent. So the ratio, excuse me, the ratio for cotangent is just tangent inversed. All right, so tangent was y over x, where cotangent is going to be x over y. So please remember though, if we look at cotangent, right, it's really just horizontal over vertical, if you're thinking of it that way. For you, it was adjacent over opposite. But sometimes, it's harder to break trig down in when you're opposite of what, adjacent to what, when we can have more set defined ways that we interpret these. All right, so let's go through an example here. We have the terminal side of an angle theta in standard position. It passes through the point 8, 15. Find the values of the six trig functions of angle theta. So when you guys do your assignments, all right, obviously they're going to be online when you turn them in. But for you to do the work, draw what it's telling you to draw. So draw a Cartesian coordinate system, draw an x and a y axis. All right, and then you're going to go, what? That 8 represents an x value, the 15 represents a y value, or a horizontal component is the 8, a vertical component is the 15. So you're going to go 8 to the right and 15 up. How do I know that? Because we're starting in the standard position, which is 0, 0. Draw yourself a triangle, all right, that fits that. Then you have to calculate the magnitude, all right? The magnitude r, it ends up being 17. How do we get that? Using the Pythagorean theorem that we did before, where we had r equals the square root of x squared plus y squared. So you have 8 squared plus 15 squared added together, all square rooted. Trig will really help if you can always draw a picture. All right, and then the angle theta, starting in standard position, means we're starting on the x-axis and we're rotating counterclockwise, okay, as the ray is going through the point 8, 15. All right, then drop yourself a perpendicular. I'm going to say that a lot this year. So we're going to go up to point 8, 15, where we marked it. We're going to go straight down. Okay, we're going to drop a perpendicular, and we're going to note it by putting the 90-degree symbol there with the box. All right, so let's write all the trig functions. Now that we got our triangle drawn, we should be able to do it. Now, if you already feel confident, you can pause the video, do it on your own, and see if you got it right. But let's take a look here. Okay, I just talked you through how we got the 17, right? Hopefully we're all clear on there. We have the horizontal component squared plus the vertical component squared, all square rooted. So that's the magnitude. And now we're going to use the 17 to help us find the rest of the trig functions. So remembering that sine of theta is going to be y over r, or you learned it as opposite over hypotenuse, or vertical over magnitude. I want you to think of it in all those different terms, because it'll make sense sometime when you're in a physics class or things like that, how you're applying. Okay? So, in this case, it's going to be the ratio of the side lengths. Okay, eventually we're going to learn how to calculate theta, but it's the ratio of the side lengths. So it's going to be 15 divided by 17. Cosine is going to be the horizontal component over the magnitude, so x divided by r is 8 over 17, or if you needed to remember the old way, adjacent over hypotenuse. Tangent is opposite over adjacent, right? Y over x, or vertical over horizontal. So the ratio for tangent of theta is 15 over 8. Why don't you stop and see if you can do cosecant, secant, and cotangent, and make sure you know which one you're flipping here. So to get cosecant, we're going to, cosecant's the inverse of sine. So I'm going to take that sine ratio and just flip it. So cosecant of theta is 17 divided by 15. So hopefully you know that secant now is with cosine, and that's going to be 17 divided by 18. And then know that cotangent means what? We take the inverse of tangent, giving us x over y. So we're going to get 8 over 15 in that scenario. So look hard at this. I think once you get used to running the ratios, finding the 3 inverse functions isn't hard as long as you understand how to do your SOHCAHTOA that you learned, right? Your sine, cosine, and tangent. All right, let's do another example here. The terminal side of angle theta in standard position passes through the point -3, 4. Find the values of the 6 trigonometric functions of angle theta. So why don't you give this one a try real quick? All right, draw yourself an x and a y axis and plot the point -3, -4, and see if you put the triangle in the right quadrant. Alright, so, and then come back. I'm going to walk through this right now. So we want to find the value. So it's -3 in the x direction, -4 in the y direction. So we should be in the bottom left-hand corner of the Cartesian coordinate system where our point is. And then we're going to take our perpendicular and go from the point -3, -4 and raise it up to the x-axis. Our perpendicular either drops down to the x-axis or rises up to the x-axis. So if we're below the x-axis, our perpendiculars come up to the x-axis. If we're above the x-axis, our perpendiculars go down. So if you drew this, all right, we would be able to get this function here. We end up in the third quadrant. Theta starts in our standard position and rotates counterclockwise. All right, so we should have -3, -4, 5. The negative values do come into play when we write the ratios, so that is important. All right, where did that 5 come from? It was calculated. How did we calculate that? All right, the magnitude is equal to the horizontal component squared plus the vertical component squared. Please note that there's parentheses around the negatives. So when you know, please remember, when you square a negative number, it becomes positive. All right, -3 squared is a positive 9. -4 squared is a positive 16. Anytime we square a negative number, it becomes positive. All right, so we end up with the square root of 25. The square root of 25 is 5. You should recognize this is a 3, 4, 5 triangle. All right, a lot of you guys, ACT-wise, they really use a lot of 3, 4, 5s and 1, 1 square root of 2 triangles. We're going to use those as well. And 1 square root of 3, 2 triangles as well that we're going to use. All right. But now that we found the magnitude of angle theta, all right, we want to be able to write the different trig ratios. Okay, nothing changes here, right? We still have a horizontal component, a vertical component, and the magnitude. So we can still use these 6 definitions that we already came up with. One thing I want to mention here that I never mentioned before, you know, some of these say like x cannot be 0, y cannot be 0. How come? Well, what happens if we look at cosecant and we have r over y? What happens if y is in the denominator? It's undefined, right? We can't divide by 0. Look at secant of r, or secant of theta, it's r over x, right? If x is 0, that function's undefined, we can't divide by 0. Cotangent of theta is x over y. If y is 0, we can't have a value of cotangent there. We're going to learn what that is a little bit later, but it creates an asymptote in the graph when we do this function. Okay, there's going to be a spot that we just can't hit because we can't have division by 0. But getting back to what we're working on here, all right, we have our triangle that we've drawn. We've calculated our magnitude r. One last thing about your magnitude will always be positive when you do this calculation. If you came up with a negative magnitude, you did something incorrectly. All right, so remember, sine is always the horizontal component divided by the magnitude. So we're going to get -4 divided by 5. All right, and it stays as -4/5. All right, if we have cosine of theta, I'm sorry, I'm going to correct myself. I can't remember if I said sine of theta should be the vertical component over the magnitude. The vertical component over the magnitude. I think I misspoke a few minutes ago and said horizontal component. Sine is the vertical component divided by the magnitude. So it should be -4 divided by 5, giving us -4/5. Its inverse, right? Cosecant of theta is just flipping that. The negative stays. All right, so it's -5/4 for cosecant. What's cosine going to be? Cosine is the horizontal component over the magnitude. All right, so cosine of theta should be what? -3 divided by 5, giving us negative 3/5, I'm sorry. Negative 3/5. And then what's the inverse function for cosecant, right? It's secant, and we flip it, so we should have negative 5/3 for secant. Remember, tangent, all right, tangent, if you remember the old way, right, it's opposite over adjacent, or it's vertical over horizontal. When we write this out though, right, tangent of theta is negative 4 divided by negative 3. What's a negative divided by a negative? A positive. So make sure that you keep track of that when you're in this quadrant. Later on, I'm going to teach you a little acronym that helps you kind of go through all that stuff, okay? But if we want to find cotangent, right, we just flip that around and it's 3/4. So I think writing down the trig function is pretty basic. I think most of you guys have done this in prior math classes, and this part should be reviewed. All right, let's look at this one now. Look at this one. This might be a little bit different. What's different? There's an equation involved now. All right, so it says find the 6 trig functions of angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0. It's easier when you have a line because you can pick any point for x and y that give you 0 there. It doesn't have to be what I'm giving you in the example. I'm giving you in the example, I'm saying it's 2, negative 1. But it can be anything else that suffices x plus 2y equals 0. Alright? Is there anything else? Maybe. Maybe not, right? What do you think? See if you can solve that. What's y equal? If we solve that, y equals what? Negative x divided by 2. So as long as whatever we substitute in for x, we can use whatever point we want to get a y. It just has to be on that line. Just has to be on that line. So, choose x equals 2, y, it's the easiest one. If we chose x equals 1, right, and we solve that, we would have to use like 1 and 1/2 for the y. Choose the first common whole number when you do this. It really doesn't matter though, because everything will work out. Because you'll just have to reduce fractions later on. Alright, so if we choose x equals 2, okay, that means y's got to be negative 1. You should be able to do the algebra between that. Okay? So, we find the magnitude, so it's 2 squared plus negative 1 squared, all square rooted. So the magnitude is the square root of 5. So we have our x is 2, our y is negative 1, and our magnitude is the square root of 5. Now we're going to find all the trig ratios, okay, for theta based on these values here. So if we look at sine and cosine of theta, all right, we're going to have to get into remembering how to rationalize a denominator. If you don't remember that, we're going to cover it. We'll go over it again in class. All right, but let's look at sine of theta here. We have sine of theta equals y divided by r. So we have negative 1 divided by the square root of 5. That's correct. However, remember we cannot leave a radical or a square root in the denominator. So we have to multiply by 1. And in this case, the 1 that we multiplied by has to be in terms of the square root of 5 divided by the square root of 5. Right? Because square root of 5 over square root of 5 is 1. I can take anything and multiply it by 1 and not change it. But what we have to do is rationalize the denominator. How do I know to choose the square root of 5? Because that's what's in the denominator, and that's what I want to get rid of. Alright, so I'm going to multiply that fraction by square root of 5 divided by square root of 5. When I do that, on top, negative 1 times the square root of 5 is negative square root of 5. On the bottom, negative square root of 5 times negative square root of 5, or I'm sorry, there's no negative. Square root of 5 times square root of 5 is the square root of 25, and the square root of 25 is 5. So that's why we get negative square root of 5 over 5. If we look at cosine of theta, right, it's our horizontal component over our magnitude. So it's 2 divided by the square root of 5. We have to rationalize the denominator again. So I still have to multiply by square root of 5 over square root of 5 because that's what's in the denominator. So on top I get 2 times the square root of 5 divided by Well, the square root of 5 again, right? Square root of 5 times the square root of 5 is the square root of 25. Square root of 25 is 5. That's why 5 ends up in our denominator there. So please remember that you have to rationalize your denominator. All your answer choices on your homework and test will not have a square root in the denominator, so you need to make sure that you remember how to do that skill. All right, lastly, if we look at tangent here, tangent of theta is vertical over horizontal. Our vertical component, right, that's the y value, is -1, and our horizontal value is 2, so we get -1/2. And it's not on this picture here, but you could start at the point 2, -1, and draw a line straight up to the x-axis and put a little box there, all right, so that you know that's where your 90-degree angle is. Then if we want to find the inverse functions, right, we just flip them around. -2 divided by 1 is just -2 there for cotangent. And when you flip these, don't flip your simplified answer. If you flip the first answer that we came up with for cosine, it makes it easier, right? When we said cosine of theta was horizontal over the magnitude, all right, it's 2 over the square root of 5. To find secant, flip that right away, because we can accept square root of 5 over 2. So don't have to undo your rationalization. So when you're doing the inverse for sine and cosine, when you do secant and cosecant, make sure you do it before you rationalize when you do that, so you don't have to re-rationalize. Cosecant of theta ends up being r over the vertical. Alright, so when you do that, okay, we started out with what? -1 over the square root of 5, and we flip that. So it just ends up being negative square root of 5 divided by 1, which is negative square root of 5. So I think we're getting the hang of this, hopefully, here. We can ask me questions if we Zoom at all or on the board. All right, and when we're in class and actually to do everything in person on those days. All right, so let's find the values of the 6 trig functions for an angle of 90 degrees. You're like, what do you mean? All right, well, look, I have 90 degrees, and this is going to lead into the unit circle. We're going to get there, okay? 90 degrees, and I have a value here at 0 and 1. My x value is 0, my y value is 1. So my horizontal component is 0, my vertical component is 1. What's the first thing you need to do there? You need to find its magnitude. Alright, so you got to find its r. You're like, but Mr. Sleddy, that doesn't make a triangle. You're exactly right. But we can still write all the ratios just because we're at 90 degrees. Alright, so we have to find r. So that's taking 0 squared plus 1 squared and square rooting it. So the square root of 0 plus 1. Alright, 0 plus 1 is 1. Square root of 1 is 1. Okay, so that's our magnitude. So we just got to be careful and think through here what's going to happen when we are here. This is going to help us define what trig functions exist, all right, at the quadrantal angles. Okay, so this one's important. So sine of 90 degrees, because we write it that way because 90 degrees is the angle, and we write the ratio, right? The ratio is the horizontal component over the magnitude, or I'm sorry, the vertical component over the magnitude. Sine is vertical over magnitude, okay, or opposite over hypotenuse. So it ends up being what? Y over r, which is 1 divided by 1, which is 1. So sine of 90 is 1. This is something that you're going to need to know, memorize, and get used to. If we look at cosecant of 90, right, because cosecant is the inverse of 90, 1 divided by 1, even though you flip them, right, it's still 1. Let's look at cosine of 90. Cosine of 90 is what? The horizontal component divided by the magnitude. Well, the horizontal component, the x component, is 0. So we have 0 divided by r. 0 divided by 1 is 0. So cosine of 90 degrees is 0. Here's what happens though. When we do secant, right, and we flip that, we can't do 1 divided by 0. So secant here is undefined. What I'd like you to pay attention to before we move on to tangent and cotangent. I keep referring to sine and cosine as sine as a vertical component and cosine as a horizontal component. If we are drawing an arrow straight up, anywhere, if you stand straight up, or we have something that's always going straight up, is there anything that has a horizontal component? No, there is no x value. If we're shooting something straight up, a rocket's going off a launch pad straight up, it only has a vertical component. Its horizontal component is 0. So I want you to think about that in the quadrantals. So sine of 90 is 1, cosine of 90 is 0. The only thing that exists there is the sine value. Now, tangent of 90 is undefined. Okay? We have a vertical, but we don't have a horizontal. So 1 divided by 0 leaves us undefined. However, cotangent of 90 is 0 divided by 1, which is 0. So you should know the quadrantal for 90. I'm expecting you to know the answer to the quadrantals for 90, 180, 270, and 360. You must know those by heart as we go through, because if I take away calculators, you need to be able to solve a bunch of trig problems and calculus problems on next semester as well. So let's find the values for this one. I want you to start thinking about this. It's -3, 0, so it's completely what? It's completely horizontal. There's no vertical component. That should tell me automatically in my head there's no vertical component. The sine value is not going to exist, only cosine, right, at this particular location. So if we plot it, we have -3, 0. We have to find the magnitude, so we're going to take what? -3 squared plus 0 squared. So that ends up being the square root of 9. The square root of 9 is 3. So our magnitude is 3 when we calculate this. Now write the ratios. I might pick up the pace a little bit here writing the ratios because I expect you to be able to do this. Sine is what? The vertical over the magnitude. The vertical is what? 0. It's given to you in the point, right? It's given to you in the point that it's 0. So 0 divided by 3 is 0. So sine of -3, 0 here, or sine of what angle is that? 180 degrees, right? A straight line. So sine of 180 degrees is going to be 0. Cosecant then will be undefined because it's division by 0. So let's take a look at what's cosine going to be. Cosine is going to be -3. That's the horizontal component, divided by 3, which is the magnitude. So -3 divided by 3 is -1. Secant, we're going to flip that, right? So it ends up being 3 divided by -3. It will also be -1. And then lastly, we got tangent. Tangent's the vertical, which is 0, divided by the horizontal, which is -3. So we have 0 divided by -3, which is 0. But when we flip this for cotangent, cotangent becomes undefined because of division by 0. -3 divided by 0 is 0. Okay? So, let's talk about conditions for undefined function values. We want to identify the terminal side of the quadrantal. Okay? If the terminal side of the quadrantal angle lies along the y-axis, then tangent and secant functions are undefined. Why is that? Alright, that's at 90, and that's at 108 or 270. Alright, straight up or straight down. So we're going to create division by 0. So that's why tangent and secant are undefined there. If the terminal side, okay, of the quadrantal lies on the x-axis, cotangent and cosecant functions are undefined. Why? Because there is no vertical component. Alright, and that will produce a division by 0 for both of those functions, because the vertical component is gone. So just kind of a simple way of knowing these. Alright, so this is a table that you should probably have in your notes, but it is one that I expect you to memorize. We will have a quiz on these at the quadrantals, and you won't have notes on it or anything fun like that. So I do expect you to know that sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, Sine of 270 is -1. Sine of 360, right, we've done a complete circle, is 0. I expect you to know every single one of these. And know, right, when we're undefined. Hey, the best way to know when we're undefined is if you know that tangent, right, tangent's a ratio of the vertical over the horizontal. Tangent is really opposite over adjacent, right? Or it's really sine over cosine. So look, anytime cosine is 0, tangent's undefined. So is secant of theta. We just talked about that. Okay, anytime sine is 0, cotangent and cosecant are undefined because that creates a division by 0 there. So really kind of pay attention. I do expect you to know and memorize this. It will be very handy when we start doing unit circles and things along those lines. Lastly, your favorite part of the lecture, right? We get to use a calculator sometimes. But you got to make sure that you're in the right mode on your calculator. So you can do mode and move it over and make sure degree is highlighted when we're doing degrees. Your calculator defaults to radian mode. So remember, on your calculator, you hit mode, go over to degrees and hit enter. Alright, and you'll be able to do like sine of 90, hit enter on your calculator. You can hit the cosine button, hit enter, or cosine, sorry, of 90, hit enter. You should get 0. Alright, so you should be able to check all the trig functions at the quadrantals. So check, sine of 90, cosine of 90, tangent of 90. Check sine of 180, cosine of 180, and tangent of 180. Do the same thing at 270 and 360. You should get all the values, alright, that were in that table that we saw on the last slide. Alright, here's one you have to be careful though. Please, we will be going back and forth in this class between degrees and radians. So make sure if you're doing a problem, if it's in degrees, make sure your calculator's in degrees. If we do radians, make sure it's in radians. If you have no idea what a radian is, you're about to, coming up relatively soon, next couple of lectures or so, when we start talking about radians, where it comes from, alright, and what it means. Alright, that's it for this lecture.